on the subject CMOS technology. The today's topic for the video lecture is design of demultiplexer using transmission gate. Welcome you all. Myself Srishel Swami, working as assistant professor in the Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. These are the learning outcomes. At the end of this session, the students will be able to design the layout of any combination circuit using CMOS logic. The students will be able to design the schematic of any demux, that is what example here we taken 1:4 demux using transmission gate in this by using the D schematic or microwind software. So this is what the demultiplexer basic diagram, where the input is only one, that is what I input, where we are getting the four output lines which are named as D0, D1, D2 and D3. So the input will be passed from or transmitted from input line to output line based on the status of the select lines. So S0 and S1 are the select lines. Based on the values, the input will be transmitted from input line to output line. So if you are keeping I as a 1, that is what input is always ready, we can keep. Then based on the select lines, if it is both are the 0 0, then D1 will be activated, D0 will be activated. If S0 has a 0, S1 has a 1, then D1 will be activated. If S0 has a 1, S1 has a 0, then D2 will be activated. If S0 and S1 both will be 1 high, then D3 will be activated. So this is what the these are the what output expressions. So Y0 is what is equal to I dot S1 bar dot S0 bar. Y1, so here Y0 is nothing but D0. Okay, you can consider the analogous terms. Y1 is nothing but D1, that is equal to I dot S1 dot S0. Y2 is equal to D2 is equal to I dot S1 dot S0 bar. Y3 is equal to D3 is equal to I dot S1 dot S0. So according to the output expression, according to the particular diagram of the 1:4 demultiplexer, now we can design the same 1:4 demux by using CMOS logic. So in that we are using the transmission gate. By using transmission gate, we can design the layout of 1:4 demux by using D schematic software. So this is what the layout diagram by using transmission gate. As for the 1:4 demultiplexer, we require total 6 numbers of transmission gates as shown here. So this we can consider as the first stage, and this we can consider as the second stage of this particular layout diagram. So in this first stage, we require the control lines S0, and in the second stage we require the control lines as a S1. So according to the combination values of the S0 and S1, the particular output line is activated. So when S0 and S1 both are the low, that is 0, the Y0 will be activated. When S0 is low, S1 is 1, Y1, like this. When both are high, the Y3 will be activated. So this design we have to make by using what? D schematic software. So we can so after designing, we can get this particular layout by using what? The D schematic software. So now we will move towards this particular design, and we can design the 1:4 demultiplexer using D schematic now. So this is, as already know, the D schematic, and it's all the icons. So directly I will start to design the 1:4 demultiplexer. So for this I requires the total 6 transmission gates. So we can prepare it, and then we can copy it, because we require to copy for 6 times, or wherever you require to copy, you can just copy, but only one time you can make it to design the particular transmission gate. So I will first of all take the NMOS. I will rotate it right. Then I will drag the one PMOS. I will rotate it left, and then I will just move it so that I can prepare the transmission gate, connect each other. Then you can make it copy. So at the first stage I require only 2. Okay, so just you can copy it, this particular entire section, because at the second stage you requires so you can just move this. You can connect this one and then you can just copy it or move this, just copy it. One more way requires. Okay, so now I have taken all 6 transmission gates. So we need to take the one input line, that is I, commonly here I will rename as I. Then I will connect and combinedly I will give the I value as an input. This as a I will combinedly give. Next I will combinedly connect here the output of this. So you can connect now according to the diagram, according to the layout you design. Now we can connect these output lines to the particular LED. So you can drag the 4 output lines Y0, Y1, Y2, Y3, where we are going to connect the LEDs at each output line so that we can get the result. Now 2 input lines we can use which are known as control lines, S0 and S1. So just you can refer this diagram. Okay, so according to that S0 will be here and S1 will be here, so that you can connect it. So 2 input lines we can take. So and then one NOT gate I requires. Just you can move it. Yes, now we can connect these lines. So here you can connect so connection, make it properly. Okay, so similar kind you can make it copy. This section you requires to copy here. You can use the connection line to connect it. So according to the layout, you can make the connection properly. So here you need to connect here properly. So once the connection is over, then you can give the input and test the result, so that the simulation you can test properly. Now 4 LEDs I can use to test the output lines. Just you can move this one at the top. So once LED is connected, you can give the name as a Y1 or just as you mentioned in the truth table. So just I will double click it, I will make it D0, or you can refer as a Y0, Y1, Y2. So Y0 first one, then second one will be Y1, then third one will be Y3, and the fourth one will be Y4. Sorry, last one will be Y3. So Y0, Y1, this third will be Y2. Y2. So once the connection over, you can now decide. So here as shown in the PPT, so here we can consider as a S0. It will be a S0. By using truth table and output expression, you need to fix out the S0 and S1. So now we can keep this circuit, this layout of this 1:4 demux for this simulation. So we will just click it the green icon and we can start the simulation. So actually now the current status of S0 is 0 and S1 is also 0. Okay, if we are pressing the here I as a 1, then Y0 will be shown as the output terminal. Y0 will be activated. Now I will keep S0 as a 0 and S1 as a 1. So in this case Y1 will be activated. So I will keep S0 1 and S1 0. So Y2 will be activated, and both S0 and S1 will be 1. Then Y3 will be activated by keeping I as a 1, I as a high. So I will change once again S0 and S1 both 0. Then Y0 will be activated output line. If I will make S0 as a 0, S1 as a 1, then Y1 will be activated. If S0 as a 1, S1 as a 0, then Y2 will be activated. If I will keep both 1 1, then Y3 will be activated. So this is what the 1:4 multiplexer. Just like by using this transmission gate, we can design any 1:n demultiplexer by using what? Transmission gate using D schematic. So this will be the end of the session. Thank you. So these are the references. Thank you.